Hello and a big welcome back to all my subscribers, and if you're not a subscriber, why not? Today is the last in my RISC-V series of myself trying to learn some RISC-V programming by writing a utility this time instead of a game. Remind you briefly what it was about. It was to do a RISC-V assembly program which would take a command line argument of a number, either decimal, binary, or hexadecimal, and show you the equivalent number in both, all three, hex, decimal, and binary. I have completed that now, and I will put this up on my GitHub page, and I'll put a link in the description down below. If you're interested, you can look at the sort of finished code and try it out yourself or modify it or do as you please with it. Before I show you it working, I just want to take a moment to remind you that I don't get any money from YouTube or Patreon or any of that sort of stuff, but I am an author, and if you would like to buy one of my books and read it, I would greatly appreciate it. You can check out my books on the publishing website xgipublishing.com and have a look there. If you like this sort of stuff, please like and subscribe and all that jazz. Now let's get on to the program. So what we've got here is, if you remember, I put everything into the source directory, and I build all the .o files in the build file, and then the executable gets output to the common directory here, or the top level directory. So just a reminder of the make file. Nothing special about this make file. It just builds using the GCC AS assembler for RISC. So that's it. And it just takes all of the source files in that directory, puts them in the object files, and then builds the target. So nothing difficult. So if we do make, it will build it all, and we have here the myconvert executable, and I'll show you that working. I can do decimal number 85, and we get hex 55, and then the binary, which you can tell this one because it's a 1010101. So I quite like to use this. We can also give it a hexadecimal number, and it will show you the decimal and the binary, and we can also do it upper and lower case, and you can just give it an integer, and it will work that out as well. So how does it work? Right, if we go into the source directory, I just look at all of them. If we look at that .h file first, there's nothing really clever in here. It's just the string that is going to be output. This one's sort of redundant. But this is, if it's 0, it just prints out 0, and then this one, it prints out the decimal bits, and this prints out the binary string. And then there's an error message. So nothing clever or complicated there. The main, it includes that file, and then it makes 3 global functions: main, error message, and 0 input, so that it can output the error messages. So the error message, if you don't put anything in as a command line argument, then it'll just tell you that you've done it wrong. If you put in the wrong number of arguments, and if you've put in a 0, then it just prints a 0. It doesn't need to do any calculations. But this is the main program here. It basically sets everything up by checking the arguments, and then it pushes all the relevant stuff into the stack for extraction later. Then if there's the wrong argument, it jumps to that and then exit. But assuming you have the correct number of arguments, it does the loop counter, presses the loop onto the stack, and then it jumps to parse command line. And then it actually never really gets here, but it's in there for completeness' sake, because parse command line will jump to the output and then it exits. So, but it's in there just for completeness' sake. If we go to the output first, it basically just outputs the result. It does a printf, and printf will print the hexadecimal and the decimal numbers, but it won't print binary numbers. So the output result gets the binary string first, and then it prints it, and then it prints out the decimal and hexadecimal values. And you can see here, then it just exits. Now, included in this is the build binary string. Now, because the default C function won't output us a binary string, I have to build that string. So that's what this function does. So it just loop converts the value in A5 and puts in either of 0, an ASCII 0 or a 1, and builds up the string until it gets to the end of the number, and then that's it. It ends the conversion and then returns to the calling function. And finally, we have probably the most complex bit of this, which is the parsing of the command line. Now, it actually starts down here at the bottom and parses the command line. It gets the string, and then it jumps to parse for that string. In theory, you could put more than one argument to this. I haven't actually tested that. We'll do that in a minute. But as it stands, it looks for the number of arguments is less than the loop, and then it goes into parse. Once it finishes parsing everything, then it comes down to this part, and it will build the binary string and output the result. So the real action, as it were, happens up here. It goes into the parse function. It loads the values. It loads the ASCII values it's going to check for as 0, an X, a B, or a 9. Then it checks for integers. So T1, if it's less than the ASCII value of 0, then go to not between. If it's greater than the ASCII value of 9, here, then go to not between. And if it's equal to 0, go to not between. Basically because you don't have leading zeros in the decimals, but you do have them in the binary or the hexadecimal. That's an assumption. Might not be a good assumption, but that's the way I'm working it. And then it basically, if it's a decimal, it just does a straightforward decimal conversion from the string to a decimal. Which is, as you can see here, relatively straightforward. And then it ends the decimal conversion, builds the binary string, and then outputs results. So actually, if you just put a decimal in, decimal is the thing it needs to build the binary string and to output the result. So if you've just put in a decimal, it just gets the decimal number, moves it into A5, and then just jumps to the end, effectively. If it's not between, it means that it wasn't an ASCII value 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. And so it now needs to check to see if the next letter is an X or a B. And then depending on whether it is, or it's a null character, which is an end of string, then then it'll jump to null character into string and it'll just fail. But if it's a X, then it's a hexadecimal and it'll jump down to that conversion. If it's a binary, it'll jump down to that conversion. Because remember, my output and build binary string want an integer. Now I realize I could use the binary string that I've already got, but the problem with that is I also need to have an integer in order to get the hexadecimal and the decimal values. So it was easier just to convert everything into decimal and then use that number. Checks for a null character, but anyway, if it is an X, it initializes A3 because that's where it's going to store the number. It starts the conversion. It skips to the first two characters of the string, loads it in, and then starts shifting the bits to get the appropriate numbers. This part actually makes it so it's only a 32-bit hexadecimal number rather than the 64, which I don't want to really deal with at the moment. And then it looks for the values and jumps to the appropriate function. If this part of the string is a ASCII number, if it's not, if it's a B, C, D, E, or F, and then if it's an upper or lower case, and it takes the appropriate action. And then the last thing it does is update the result and loads the next character, or moves on to the next string, loads that character in, and then jumps to the conversion again. Assuming everything was converted correctly, it'll jump to end conversion, and then it jumps to the end of the loop where it updates the values and then calls the appropriate output. If it's a binary number, it does the same thing. It skips the first two, the 0B, then just checks with the 0 or 1, converts the number into an integer, loads the digit into A3, and then continues the conversion until it's finished that. And at the end, they go to end loop, increments all the good stuff, and it jumps back to the command parse line, where it either goes on to the next value or comes to the end and then outputs the string. So that's it. It does work. As I say, I didn't actually test if it will do multiple values on one command line. No. It takes the first one and that's it. Now, I probably could update it to do this, but I'm unlikely to do that at the moment. Not really interested in doing that. As I say, I will stick the code onto my GitHub page, and I'll put a link in the description for that. But that's pretty much it for this series. If you're interested in looking at more RISC-V assembly programming, let me know, and I will do another series basically on assembly language programming on the RISC-V CPU. But other than that, thanks a lot. Once again, if you like these sort of things, like and subscribe and share them around and push the bell and all of that stuff that everybody always tells you on YouTube. So do all that for me. All right, thanks a lot, and I'll see you soon.